Okay, so let's start with some examples. So I think this chapter is kind of fun. I think if you really understood everything we've learned about, especially in Chapter 9, this stuff should come pretty easily. So we're going to do our first situation where we have, right, two population means, or we know the standard deviation, so right, that's a z-test, and we have independent samples. So again, the process is the same. State the null and alternative hypotheses, determine our alpha, calculate the test statistic and p-value, and make a decision. So again, this is the same process that we learned about in Chapter 9, right? We have a point estimate. In this case, it's the point estimate is the difference between the two population means, right? That's what we're ultimately interested in. The standard error, right? We calculate that. So the formula is slightly different, but you still see the square root of the population standard deviation divided by n, right? So again, it's very similar in terms of the equation. And remember the standard error, right? It's a standard deviation. What's it the standard deviation of? Well, it's the standard deviation of the sampling distribution of the difference between the two means. We want to do interval estimates, we have that, and then otherwise we have our test statistic, in this case z, right, because we know the population standard deviations, right? It's the difference, the numerator is the difference between the point estimate and whatever it is we're interested in looking at. So in Chapter 9, this was mu of the population that we're looking at. Here, this is the difference between the populations in terms of their means. Typically, we set this equal to 0 because that's what we assume the difference between the population is, and then divided by the standard deviation, which is the standard error, which is the standard deviation of the sampling distribution for our point estimate. So again, same concept, right? We have a null hypothesis, we have alpha, we have a test statistic that we compute by finding the difference between the point estimate and some other value divided by the standard deviation, right? And from that we can determine a p-value or use the critical value approach to determine whether or not to reject the null hypothesis. So let's actually just jump into it and do an example. So suppose you're responsible for making arrangements for a business convention. You have been charged with choosing a city for the convention that has the least expensive hotel rooms. You narrowed your choices to Atlanta and Houston. So we have an Excel file that contains samples of prices for rooms in both Atlanta and Houston. Because considerable historical data on the prices of rooms in both cities are available, the population standard deviations, they're known, for the prices can be assumed to be $20 in Atlanta and $25 in Houston. Based on the sample data, can you conclude that the mean price of a hotel room in Atlanta is lower than one in Houston? So again, we're comparing the prices in two different populations, right? In this case, cities for Atlanta and Houston. So I have a couple slides that show you the Excel options and how to do this, so we're going to do that together. I do just want to point out that when we go to data analysis, these are the options that you'll be using for when you have two populations that you're comparing. First, we have the t-test paired. Right, so we'll do that example down the road in a little bit. Right, we have the z-test for two sample means, which is what we're going to do in this video, and then we have two tests when we have two samples. These are independent samples, so we're going to choose unequal variances. So again, we're going to do videos for these two later, but for right now we're focusing on this one. So actually, let's go to Excel and let's look at what's going on. So let me zoom in a little bit so you can see. So here's the data in column A and B. These are the prices for hotels in Atlanta and Houston. So notice that these rows, though, they don't really have anything to do with each other other than this was observation 1, 2, 3, as well as observation 1, 2, and 3, but they are independent, obviously. So just to clarify that. So what we want to do is we want to compare, right, the means for hotel prices for Atlanta and Houston. So to do this, we can go up to data up here in the corner, or excuse me, up here above, and then over here in this corner we could go to under analysis, data analysis. So data analysis, right, and if we scroll down we have those options that I just showed you about. Remember, we are selecting the z-test, right, because we know the population standard deviation, right, for two sample means. So hit OK. and another box is going to appear with options. So we have to fill this in. So for the first one, it says the variable range. So we need to select the data for the first variable. So this is for Atlanta. So just select those observations, and then go to range 2, which is Houston. Select all the data for Houston. Notice that they're unequal in terms of the sample sizes. That's okay. What happens is the leftovers get cut off. I think for independent samples. Maybe they use. Let's look at the output. So anyways, hypothesized mean difference, right? It's 0. We're assuming that there's no difference. For the variance, so this is a little tricky, because if we go back to our example, right, the population standard deviations are 20 and 25. But this is asking for the variance, so make sure you enter this correctly. The variance, right, you can just take the standard deviation and square it. So for 20, that's 400. And for variable 2 for Houston, 25 squared is 625. I select the labels box. I checked that because up here in variable range, I selected the label. Sorry, I can't scroll up, but how it said Houston, Atlanta, I put that in, and I'll show you why in a second. So if you do include the labels, check that box that says labels. Alpha, you can change this here if you want 0.01, 0.05, whatever. So I think the default's 0.05. And then output range, just put wherever you want to put your data. So I already have the output, so I don't want to overwrite it. So I'm actually going to put it over here so that we can see it again. So then hit OK. And then your results appear. So the results that just appeared are actually right here, because I've already did these analyses, but I just wanted to show you how to do that in Excel. So we can look at the output. So it shows our means for our 2 samples. So for Atlanta, it's $91.71, meaning that the average price of a hotel in Atlanta is $91, and in Houston, it's $101. The known variances, right, we entered that. We have observations, which is the sample size, so they do use all those samples for both Atlanta and for Houston. And then hypothesized mean difference is 0, right, we entered that. And then we get the output here in terms of the Z statistic, the critical Z values for 1 and 2 tailed tests, and then our P values for 1 and 2 tailed tests. So if you remember in the example, it said, can you conclude that the mean price of a hotel room in Atlanta is lower than in Houston? So it's actually a 1-tailed test. So if we were to look at 1-tailed test, P is less than 0.05, because I believe that was our alpha. So we would reject the null hypothesis and conclude that, yes, it is cheaper in Atlanta compared to Houston, right? So that's it. And we can also look at the critical value for Z. Now, I'd like to point out that if you did do a 2-tailed test, right, your p-value would be 0.07. So at the 0.05 alpha value, you would not reject the null. You'd fail to reject the null. So I think this is important because it points out if you have a 2-tailed test, it is more conservative regarding type 1 errors. You're less likely to make a type 1 error when you have a 2-tailed test. So in that regard, it's more conservative. You're less likely to make that type 1 error, which is when you say, hey, we reject the null, when in fact you shouldn't have, because the null in fact is true. So in that regard, be careful with that. Some people knowingly or unknowingly take advantage of this, exploit this, however you want to say this, because they'll look at this and be like, oh, it's significant, but this one isn't. So we'll just assume it was a 1-tailed test. But what if you were saying, like, hey, I don't know which city to choose between Atlanta or Houston? In that case, you'd want to have a 2-tailed test, because you'd be like, I'm not sure which one is cheaper or not. I would like to look at the difference in prices, but I don't know which one's cheaper. That's a 2-tailed test. So according to this, in terms of statistical significance, they're not different. So you wouldn't be justified in choosing Atlanta over Houston or whatever. So I just like to point that out. I did write the null hypotheses and things like that down there, so you can look at those. So overall, that's the process. It is pretty simple. in terms of just, select whatever test is appropriate, enter a couple boxes in terms of information. Then you get your output. You can look at your p-values and then determine whether or not to reject the null hypothesis, and you come to a conclusion. So all that information is here. I showed that in the slides, so you have that type of information. So I hope that makes sense. If you want to see another example or you have questions, just let me know.